Chapter 3, number 20. Consider the vectors a and b as shown in the figure. Which of the other four vectors in the figure best represents the direction of the following things? Now, the direction, but not probably the magnitude. And that's okay. So, in part A, we want to add, and I'm going to give these guys different colors. So let's make this the blue vector, I guess as it is. And let's make this a red vector, just so I can add them up. So part A says add the blue vector to the red vector. So the way I can do that is take the blue vector, which looks something like that, and then add the red vector, which certainly looks a little like this. And we just move it to be tip to tail. And that gives us what I'm going to do as a purple vector, which is their sum. So this is roughly a plus b. And if we look over at the figure, this is basically like vector e. Right? Vector e goes in that direction, and a plus b goes sort of in that direction. In part B, we are asked for a minus b, and we remember that a minus b is the same as a plus negative b, and negative b is the flip. So negative b goes like that. We flip b, and so it goes the other way. So if I now take my a, which looks something like this, and I add in b, or negative b, which goes over like that, then my output looks something like this, and this is a minus b. And if we look on our figure, that is pretty close to f in direction. Right? F goes this way, and a minus b goes that way. Okay, and then c. And in C, we want b minus a. And so we remember that b minus a is the same as b plus minus a. So I need to construct what minus a would be. Minus a is that, shall we say. And so we take b, and we add in minus a. And we see that the tip-to-tail construction gives us this, which is d. Really, this would be b minus a, and that's roughly in the direction, at least, of d, because d goes like that, and our vector goes in the same sort. We could actually also look at it in a different way, which is sort of interesting. B minus a can algebraically be written as minus of minus b plus a. If you redistribute that minus, you'd see that it comes back to b minus a. And the vector arithmetic is commutative, so I can turn minus b plus a as a minus b. And so we get that part C should be the flip of part B. And if we look up here, D is in fact the flip of F. That D plus F would be 0. So that's a different way to get to the same answer.